5.3 Solving trig equations. Number 1, solve 2 sine x minus 1 equals 0. So your goal is going to be to isolate your trig function. So you need to get sine x by itself. So I'm going to add 1 to both sides. That gives me 2 sine x equals 1. Divide by 2. I get sine x equals a half. Well, if you remember, sine, all students take calculus, is positive in the first and the second quadrant. Now keep in mind there's no restrictions, and if you remember, all of your trig functions go on to infinity in both directions. So we're going to have to do this in 2 parts. So one, we have to figure out in our unit circle, which I've put over here, where sine is a half. And since I'm in the first quadrant, sine is a half at pi over 6 and at 5 pi over 6. So that's pi over 6 and 5 pi over 6. But in order to tell me that sine's going to be a half for every rotation of my unit circle, basically as we go around, I have to add 2 pi every time to get back to this quadrant and find my coterminal angles. I have to add 2 pi again and again and again. There's nothing that I can add to this first one to get to the second one that would get me back to the first one. So if they're next to each other, you're going to have to add 2n pi to each of these. The n basically just means how many times you go around the unit circle. So if I go around the unit circle once, I'm adding 2 pi. If I go around twice, I'm adding 4 pi. If I go around 3 times, I'm really adding 6 pi. So if you have 2 functions and there's no restrictions, it doesn't say 0 to 2 pi, being on your unit circle, you have to split it up into 2 parts. Pi over 6 plus 2n pi, and 5 pi over 6 plus 2n pi if they're next to each other. Next problem, I have sine of x plus, and normally I don't put a 2 for a square root, but this particular program makes me put in a 2, otherwise it puts this weird funky box there. So I'm going to leave it there. So I need to move my signs together. That gives me square root of 2 equals negative 2 sine of x. Get rid of my negative 2. That gives me the sine of x equals negative root 2 over 2. And that sine is negative in my 2 bottom quadrants. So that means I'm looking for where sine is negative square root of 2 over 2, which is 5 pi over 4. And the other one where it's at 7 pi over 4. And since these are next to each other, 5 pi over 4, start with that part, and 7 pi over 4, I have to add 2n pi. Because if you remember, the solutions for this, if you put them on the calculator, your trig functions will go on and on and on and on. So there's many places where it hits. So you have to tell it, in order to go from this one to this one, I have to add 2n pi to this one. If I want to go from this one to this one, I have to add another 2n pi. It gets me to each subsequent coterminal angle. Number 3, 4 tan x minus 4 equals 0. So we're going to add 4 to both sides. That gives me 4 tan x equals 4. Divide both sides by 4. Gives me tangent of x equals 1. And tangent is in 2 quadrants. Or positive in 2 quadrants, positive in the first and second. You may notice that in this case they're across from each other, whereas before in the other 2 problems they were next to each other. So there was 90 degrees from the first quadrant to the second, but there's 270 between the second and back to the first. So you can't do one thing to hit both. Whereas on this one, if I go in the first quadrant, you can see in the first quadrant, this doesn't have it on here, but tangent is 1 at pi over 4 and 5 pi over 4. And so in order to hit both of them, I'm just going to do pi over 4 plus, there's 180 degrees, sorry, that was the bell, from here to here, and another 180 degrees back. So I can just add n pi and I'll hit both. So instead of saying pi over 4 plus 2n pi to get all the way around to this one, and 5 pi over 4 plus 2n pi to get back to this one, I can use plus n pi since there's pi degrees between each one. As long as they're across from each other, you can do this. Because if I double check pi over 4, if I go once, it gives me add 1 pi. That's pi over 4 plus 4 pi over 4, which is 5 pi over 4. So without having to write two different answers, pi over 4 plus n pi will hit the first one, and it will hit 5 pi over 4. If I put a 2 here, it'll go back to this one. If I do 3, 4, 5, 6, 7 for the n's. So this is my answer for 3. Number 4. 4 cosine squared x minus 3 equals 0. So I am going to change my pen width. Let me change my colors. Okay. So I'm going to add 3. That's 4 cosine squared x. This pen is not very thick. Equals 3. Divide by 4. Gives me cosine squared equals 3/4. And then I need to square root. And don't forget, once you square root, you have to put a plus or minus in front. That gives me square root of 3 over square root of 4, which is cosine of x equals plus or minus square root of 3 over 2. Now you'll notice with a plus or minus, that means you're in all 4 quadrants. So again, I can find one answer to take care of these two, which in the first quadrant, your cosine is going to be square root of 3 over 2 at pi over 6. So if I do pi over 6 plus n pi, it will get me both the pi over 6 and the 7 pi over 6, these two that are in the first and the third quadrant. So pi over 6 plus n pi will take care of these two. Then, let me switch colors. Then to take care of these two, I'm at 5 pi over 6. If I add n pi, I'll also take care of the 11 pi over 6. So 5 pi over 6 plus n pi will take care of the second quadrant and the fourth quadrant because there's 180 degrees between those when they're across from each other. And those are my answers for 4. Problem number 5. Solve cotangent of x cosine squared x equals 2 cotangent of x. You may notice that you have a cotangent on the left side and on the right side, but you never want to just divide both sides by cotangent because that might get rid of some of your answers. You always want to move everything over to one side instead. So this 2 cotangent is going to get moved over to the left. So that gives me cotangent of x cosine squared x minus 2 cotangent of x equals 0. And then you'll notice that in this term, the first term and the second term, they both have a cotangent in common. So we're going to factor out the cotangent. So cotangent of x cosine squared x minus 2 equals 0. So then I'm going to set each one equal to 0. Cotangent of x equals 0. Cosine squared x minus 2 equals 0. So if cotangent equals 0, then that means tangent is undefined. And tangent is undefined up here and down here. And again, they're across from each other, so I can do one answer to hit both of these. So that's going to give me pi over 2 plus n pi will hit the one at the top and at the one at the bottom. Because if I add a 1 here, that'll add 2 pi over 2, which will hit my 3 pi over 2. Now over for my cosine squared minus 2. So if I move, let's change colors, let's do red. If I move my 2 over, that gives me cosine squared x equals 2. When I square root it, I get cosine of x equals plus or minus 2. And plus or minus 2 is larger than 1. And remember, sine and cosine aren't greater than 1. So this is extraneous. That part doesn't give me any answers. Your cosine can't be bigger than 1 or less than negative 1. This time, I want to solve 2 sine squared x plus 3 cosine minus 3 equals 0 over 0 to 2 pi, which means if you see the 0 to 2 pi, it means I'm restricting my answers to only the unit circle. So I only want answers that are on my unit circle. My answers have to be smaller than 2 pi. So if I have to choose between 0 and 2 pi, I choose 0. That's a really bad less than. They have to be less than 2 pi. So I've got 2 sine squared x plus 3 cosine minus 3. I want to try to get everything. Sorry, that's the bell again. I want to get them all to the same trig function. So I'm going to make everything be cosine. So in place of sine squared, I'm going to put 1 minus, cosine squared plus 3 cosine x minus 3 equals 0. Go from here. So that's 2, distribute, minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Combine my like terms. Okay. It's going to be easier for me to factor if I don't have this negative in the front. So I'm going to divide everything by a negative 1, and I'm going to do that on the next screen. So if you haven't written it all down, you might want to pause it. Pause it before you go on to the next screen.